So we're going to start with assignment 8 here. And what assignment 8 is we're supposed to look, find the BST, find the BST program, and create a new class called MyBST that extends BST. And what it has in addition is this height, this height method, which returns the height. The height is the number of how the longest path down to the bottom of the tree. Today I'm going to use Visual Studio 2019. I'm going to name this program I'm going to name it BST assignments. How's that? I'm going to name it BST assignments. So I'm going to open a new project, and it's going to be a Python Windows console project, this thing. And I'm going to go to next, and I'm going to name it BST assignments. And I'm going to put it someplace so I have it. So I think I will put it, I've been really having trouble with this. I'm just going to put it on the desktop. I've been having trouble storing stuff in my OneDrive, so I'm just going to put it on the desktop. And I'm going to call it BST assignments, create. And so here we are. It's called BST assignments. And so I'm going to put, I don't know. Okay, so I'm going to put the thing that tests this, what is this thing? This test BST thing, where it inserts a bunch of stuff in. Well, all right. I'm just going to put this in there. Let me get the answer here. And I'm going to get this to work first. So I'm going to copy this down to here. I'm going to copy it, Control C. Go over here, I'm going to do Control V to paste it. There we go. It's a nice program there. And then I have to add my BST. I got to add the BST class. So I'm going to go back to the BST class. And I'm going to go down and copy it. Get the answer. Anyway, so these are all the things that it comes with. You can find something, you can insert something, you can delete something, you can test this. Oh, you can do an in-order traversal, I guess. I'm not sure. Okay, anyway, so let's get the answer. Insert in order. What's in order helper, I wonder? Well, copy this, Control C, go back to here, and I'm going to do, go click on the, right here, this assignments thing, do a right click, and I'm going to add a new item. It doesn't matter, but I'm going to name it BST. Just name it that. All right, so I've got BST. I think it's in the clipboard. Control V. And now I've got this BST class. Up at the top, it says BST. Okay, good. So that's great. Now I'm just gonna run and see what happens. See if it does anything. This thing popped up. Ooh, what do we have here? Inorder. So these are different ways of traversing through the binary search tree. Great. Okay, well, anyway, it works. Something works. And it would be this thing here that works. So that's great. Oh, this prints the trees. Okay, I guess we don't. No, we don't really need those. Okay, so all right. So the first thing we're going to do is do assignment 8. Well, I'm going to do this. I'm going to go. I'm going to do class my BST, and it's going to be derived from the BST class. My BST is going to be derived from the BST class, and apparently this thing, oops, DEF init self, and then I need to do this. We start by initializing a BST, the init self from the BST class itself. Do I really know what this is? Not really, but I just type it in and I know that it works. And then, so that's that my BST thing. And then I can do my height. So height looks like this. Define height of self. And I'm going to return the self height. I'm going to create another method called height1 of the root. Okay, and let's do this def height1 self comma root, and that's going to return if the root is none, then return -1. In other words, if it's an empty tree, else return 1 plus the maximum of self. Oh, I see. Self dot height 1 of the left side with the self dot height 1 of the right side. Okay, so this is like a recursive function where you're trying to figure out the height of yourself. And so when this is called, you actually are going to return the height1. Height1 is this other special method that we wrote. It's down here. That's this. And so this is going to return the height1 of the root, which is your starting point. And then this is the this calls itself, you see, and it says if root does not have any, if it's basically null, then it returns -1, which means that it's empty. Otherwise, it takes it's going to be the height is going to be 1 plus the maximum height, the maximum of, well, first it's going to figure out the height of the left a tree that is hooked to, that's hooked to it. and then it's going to find the height of the right tree that it's hooked to, and it's going to take the maximum of that, and that's what this value going to be. And so you add 1 to that, and then that's what it returns. So this is going to keep on going down. This is going to keep on calling itself. It's going to keep on calling itself on its children until it gets down to here, where it hits a child that's got it's where this is null, this does not exist, or this does not exist. And when you call this on something that does not exist, you get this here. You end up getting this, and so you're returning a -1. So anyway, that's how this works. So how do you test this? Well, let's so let me okay, so let's I think we can get rid of all this. Let's get rid of all this. Okay, so we start by defining a tree, and then we're gonna input something. What are we gonna input? Let's input. We want it to look like this. See, okay, so we've defined that. Note that the height of an empty tree is -1. If a tree has only 1 node, its height is 0. And so we want it to look like this when it runs. Okay, so I'm just gonna copy this, and I'm gonna go back over here. And I'm going to put this as a comment somehow, some way. I'm going to do ... space, paste, enter, enter, ... I mean, those are single quotes. It doesn't like that? Doesn't like that, huh? Oh, well. What if I do this? Oops. Okay, that's better. All right, so the first thing it's going to do is it's going to say print the height of an empty tree is quote comma tree dot height. I think. I really think that's true. That's correct. Why are all these squigglies? Oh. 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 Ah, look at that. They all go away. One little colon. Okay, I'm just going to run this and see what it looks like. Why am I... Looks like it's running. Why is it... Oh, because... All right, so let me run this. Oh, I see what's the matter. It should be my BST. Let me stop this. Let's try it again. Yeah, all right. We're cooking with gas. All right, so great, we've done that. Let's do the rest of this. Enter S equals input, enter integers in one line for tree 1. What's a 1 there for? Tree separated by space. All right, that's fine. And then quote, and let's do a space. Dunt. All right. And so we have S, and then we're gonna turn it into a nice list. So I'm gonna do list 1 is equal to, these are all integers, so I'm gonna do int of x or x in s dot split. All right, so we're going to split s on the spaces, and it's going to and so for each digit, so it'll be a bunch of digits. For each one of them, we're going to convert it into an integer because really it's a string. And then that's going to get stored into this list 1 thing. And then I'm going to go, then I have to insert it into the AVL tree, right? Yeah, I got to insert it into the AVL tree. So for each element in list 1, do this, tree.insert E. So insert that dude right into that tree for all of them. And then when I'm done, this is, yeah, too bad. The spacey thing is weird. I'm gonna, all right, whatever. So this is gonna insert it in, and then I need to display it out. How did we? Let's see. This is an AVL tree. Okay, well, I can just do. Let's see. I'd like to display out the tree. 27. Let me try to look at some of these other exercises here. This one is 1. Well, I guess I can always do for each. So let's display out the thing. So I'm going to do, how did I do the, see, we did this Inorder thing. Let me look back on this here. This is the BST thing. Delete. Pre-order helper. Oh, how did it go? Pre-order, in order. In order. I'm just going to do. I'll just do in order. So it's in order. Okay, let me go over here. I think this is, this is the stuff I deleted all out, right? And but in here was how we display out. Okay, so so I'm just gonna go tree.inorder, just so I can see it. I'm gonna do tree.inorder. I'm gonna do this here, just so I can see it. So I'm going to do right here. Tree in order. That'll display it out. And then I want to say what the height is. Print height is, oops, height is comma tree dot height. And I got to do a, I'm just going to do a print. Character term there just to make sure I get one there. Okay, so I'm going to run this, see what it looks like. Enter integers one line in one line for tree separated by space. All right, let's see. Let's go find our original assignment. It looks like this: 9, 8, 9, 8, 97, 78, 77. Copy, paste, enter, and it says the height is 3. The height is 3. Now this actually shows how it is displayed, or this is an in-order traversal, so it should be in sorted order. It is in sorted order. I guess I can. Okay, to make it look like this, it's going to be something more like this. Let me shut this off. It wouldn't be that. It would be this. It would be. The are inserted. Okay, are inserted into the tree. So I would do, when each of these gets there, I'm going to go print e comma end equals that, so it doesn't do a return. Yeah, all right, I think that works. And then so that's going to print out all the things, and then when it's all done, I want to print out this thing. Oh, I want to print out this thing. Let's see what this does. All right, so anyway, that is assignment 8.